Hi, my name is Alex Pluto and this is Package Main. In previous episode, we've built a program in Go which captures image from web camera and uses face box to recognize the face. Also, we've deployed this program to Raspberry Pi. But that's not smart, as we just print the name to std out. And this time we will make it a bit smarter. We will teach our program to greet person when it can recognize the face, and we will use text-to-speech and Google Speech API. Let's start with text-to-speech. Google Translate API has an option to get an audio from the text. It's easy to implement this API call, but I already prepared a package so we can just use a function from it. So here we have a code we've written last time. And let's go get the package to make a text-to-speech. So I'm using go-get and the package in my account. Alright, this package caches results. So when we have the same text we need to make a speech for, it will just play the file we already have. To play the audio file, our package will use our mix player command line tool, which is already included in Raspberry Pi. So let's modify our file and greet the person when face is found. Also, in last episode we didn't check the very important factor that we need to have a threshold for the confidence. So let's add this condition here. If confidence is higher than 50%, we will do greeting. And now let's initialize the speech object before the loop. And first of all, let's import our package and define the speech object. Speech will be http://speech. And what we need to set is folder and language. So folder, for example, can be just audio and language English. Cool. And now, when confidence is higher than 50%, let's call just a function speak with a text. For example, is that you and the name. Also, I think that for better debugging, we can move it before the confidence. Cool. Now we can say something to user. But we don't want to do it every time we can recognize the face, because we do it a few times per second. So let's greet the person only one time in 12 hours, for example. To do so, I will create a map called greetings is a map. As a key we will have a username and value can be time. So we will save at what time we greeted the person. And let's create a small function is greeted where we can send the name and result will be a true or false. Let's check if we have the value in our map. For example, greetings from name, right? And we return that it's okay. And let's compare with current time. So now is before G add hours. Cool. So let's check this. We can do it here. Greeted is greeted f name. And let's check here if confidence is higher and not greeted. And also let's add this to our log. just for debugging. And also I forgot to initialize my map, so actually it's make like this. Cool. I don't use mutex in greetings var because all operations are done synchronously. And also let's check the error in speak function. I also forgot about this, so if error is not nil, let's just print it. Let's print something like unable to do text to speech. Cool. Now let's try to build our program and send it to Raspberry Pi device and see how it works. As you remember, we need to set GoOS and GoArch environment variables. GoOS is Linux and GoArch is ARM. Go build -o capture, right? Cool, we have our program built. Now let's send it to Raspberry Pi. Sync capture my address and home folder. Cool, let's try to execute our program on Raspberry Pi device. You should have a speaker connected to your device, but I don't have it, so I use HDMI cable and TV. It also works. I already have a SSH to my device, and I just go here and run my capture binary file. Let's wait till it connects to web camera. Alright, I see it's green now. Let's try if it can.
Oh, is that you, Alex? Oh, is that you, Alex?
Alright, now it works, but as you can see, we have one issue that it continues to greet me. And I can see why it happens, because we forgot to set to add a value to our map. We do here, just set greetings, fname equal time now. Cool. Now let's try to parse the user voice input. And first of all, we need to record the voice into a file and then send this file to Google Speech API. To record the audio from input device, we can use different command line tools. And in this example, I will use a SOX and rec command line tool. So first of all, let's install it on our Raspberry Pi. So it will sudo apt-get install SOX. Yeah, it's already installed, but here's a comment how to do it. And also the rec command line tool will be installed together with SOX. And let's try to record the audio. So we can use this rec. And also Google Speech API requires us to have an audio in specific format. And I checked that we need to have a rate 16,000 and we should record only in one channel. And here we should set the name of the file like test. Alright, here's an error because we need to set an audio device which we will use. In my case, I have a microphone built into web camera, so I need to set the ID of this device before running the rec command. So we need to set the audio dev environment variable. In my case, it will be HW10. On your Raspberry Pi device, it may be different. Let's try to run it. 1, 2, 3. Yeah, it's recording. Let's stop it. Rec command line tool has some options. And let's set a limit of our recording. For example, it will be 3 seconds. So to do so, we can use the option trim from 0 till 3 seconds. And let's check this. Alright, it's recording for 3 seconds and then it stops. Now let's implement this in Go. We will use exec Go package to run it from Go function. I will create a function record, and as input arguments I will have a file name where we will save our audio, and I think that's all. I will return error. Let's initialize the command. It will be exec command rec, and then let's just do the same as we did in command line. 16,000 channel 1, then we have a file name, and at the end we have 303. And also we need to set this environment variable. How we can do this? We can use os environ, and let's append new variable there. So it was audio dev w10, and there is a command env equal env. And now let's just call the run function, and it will return error, so we will just return cmd.run. Cool. Let's get back to our main function. By the way, here we should say continue and don't go further. Now let's record the audio into a file. Let's generate a file name so it will be unique, and for this we can use something related with time. Dot time now dot unix nano, and let's record it into this file and basically do the same with error. Unable to record user input. Error, continue. And in case everything's fine, let's just print some debugging information. User input recorded into file name. And let's build our command again and try to run it on Raspberry Pi device. Cool, there are no errors. We do rsync, go back to device and capture. Let's wait a little bit.
Oh, is that you, Alex?
And now it's recording, I think. And we can see greeted true, and it doesn't say anything. Cool, let's stop it for now. And so we saved into this file. Let's just try to play it. To play, we can use OMX player, just the name of the file. And now it's recording. Yeah, so it's recorded. Let me fix some small typo here. Now let's send our audio to Google Speech API. But before, we need to create an application in Google Developer Console and get an API key. For API key, we will use a service account and download a JSON file. I already downloaded this file and sent to my Raspberry Pi device to home folder. Let's go back to our working environment. And first of all, we need to get the packages we need to work with Google Speech API. So I'm running go get command. So it's already installed on my machine, but you can see the list here. Now we will write a function to make a speech to text using Google Speech API. So let's call it speech to text. We will send a file name because we will send it to Google Speech API, and as a result we will have a text and we will have error. In case error is not nil, the text will be empty. So we have this speech.json key. First of all, let's initialize our client using this key. So it will be speech.newClient. I hope speech is imported. Cool. And new client needs context, as I remember. Context background. So we'll set context. And we need to send our key. And for this one, we will use this option package. Let me import this. Option with the service account file. And then we pass the name to our file. So it's in the same directory, speech.json. It's already on my Raspberry Pi device. And new client returns as a client and error. Let's check if error is not nil. We just return empty string and error. The next thing we should do, we should read our file and get the bytes slice. So we can use io-util package and use a function read file name. So called data or body error. Basically do the same as error. Cool, now we have a client, now we have our file contents. Let's send it to Google Speech API, and for this we can use client recognize function. We also need to send a context here, and the second parameter is a recognize request, and we have it in this package. So let's import this like a speech pb protabuf dot recognize request. Cool. We have config here and audio. All right, let's config is same speech and the same for audio. Recognition audio. In config we should set a rate, a language, and some other parameters if we want, and also encoding. So let's start with encoding. Our encoding is linear 16, so it will be speech pb recognition config 16. Then we should set a sample rate is 16,000, and we should set a language, and for example it can be English US. We're done with config. Now let's send an audio contents. There is a field audio source. Alright, recognition audio source. Cool. So same speech b and to the recognition audio content. The field content is a slice of bytes, so it's good, it's body. So recognize function will return us some response and error. And let's return this error if it's not empty. And now we can iterate over our response results. So we can do like this result, range response results, and each result object will contain a list of alternatives. So let's also iterate over this. Range result dot alternatives, and let's return the first one with higher confidence. So let's return alt dot transcript is a string and no error And in case we didn't return anything, let's return empty string and let's generate some error. Unable to do speech to text. Cool. Alright, our function itself is ready. And now let's call it from main func. Alright, when input is recorded, we call speech to text and we send the file name. Alright, and here we will have a text and error. In case error is not nil, unable to do speech to text error. Actually here error is not clear, no results. Print the text in case we have it. Alright, let's try to build it again. Alright, this time there are some errors. 152. Of course, we forgot it. And 53. Yep, the same. Build it again. Cannot use content. Alright, it's because it should be a pointer to recognition audio content. Let's try to build it again. Alright, this time build is successful. Let's switch to our device and run the capture. Pool is green.
Oh, is that you, Alex?
Yes. So it's recorded. Cool, we have the yes text here. Let's try to run it again. And alright, sometimes on Raspberry Pi device we have this error when unable to start streaming. Just start it again.
Oh, is that you, Alex?
No, it's not me. Yeah, we have this 3 seconds delay. Cool, we have a text. You see, same as I said. Let's stop it. Now let's try to parse the text and do something, for example, reply to user if it's a yes or no. We will do something very straightforward and simple. For example, if strings contains, very basic, text yes, we will say something. Let's move it here. Or if no. We have our object speech, so we can speak to have a good day name. Still have this f name. In case user said no, let's say something like, oops, sorry. Alright, let's build it. Yeah, it's not this. We'll send it to device. Alright, let's switch to our device. Let's run it.
Oh, is that you, Alex?
Yes.
Have a good day, Alex.
Thanks. I hope it was interesting and helpful, and in the next episode we will add a natural language processing feature to our program, so stay tuned.